Okay, these try. I want you to have a go at them, and I'll write the answer and the restrictions, and then you can just check. So the answer for A is log base 3 to x. Okay, so if you did that, well done. And the restriction is pretty straightforward because it's just got an x with the argument. X is greater than 0. Okay, B now. With B, hopefully you did your factoring and you did some cancelling out and you got log base 2 to x plus 3 on top and on the bottom x plus 2. Okay, that's the simplified expression. Now, how are we going to deal with the restrictions? So if you did you got to go back to these originals and did your factoring and made them greater than 0, you would have noticed that the restriction is x is greater than 3. Okay? Now, moving on to example 4, determine an expression in specific terms, okay? Specific terms. So you'll be given some logs that equal a specific letter or number, and you have to work down. So what I'm doing is I'm looking at the question given, so I have given log 20, and I have to get it into a log 5 or a log 4. Well, that was pretty easy because log 4, this should be a plus sign, pardon me, plus log 5 is really these two times each other, which is that. And now I know what log 4 is. It told me right here, log 4 is y. And I know what log 5 is. It told me there is x. So I have my answer. Okay. Now the next one, I have log 100. Well, the answer is really, some people say, oh, it's 2, Mr. Rabbit. Well, if I evaluate it, you're right, because there's a base 10 there, invisible, and 10 squared is 100. But we're not doing evaluating here. We're using specific terms now, so you have to watch out and follow. Okay, so I'm using 100. Okay, so remember, you're thinking 5s and you're thinking 4s. Okay, so I'm thinking of two numbers. I'm going to use the product rule that I can get 100. So I thought of 25 and 4. Why these numbers? Because 4 is a good one, because 4 is right there. And this guy is really 5 squared. Okay, so you sort of, it's like puzzles. You're trying to take something to fit a puzzle. So now I can write it as 25. Again, I made a mistake. It's plus log 4. And remember the 2 comes down. Whoop, another mistake there. Plus log 4. And now I take this guy, which is x, and the 2 just comes down, and this one's y. So there's my answer. Okay, so again, I'll go through these ones because these ones are trickier. And so just sort of follow along. I want you, when you're doing these specific term business, I want your brain, here's my brain, little bubble. You want to be thinking 3 rules. You want to be thinking the power rule. Can I use the power rule to solve this question? Can I use the product rule? That's times. Or the last rule is the quotient. Okay, quotient. All right, so what am I going to use? Sometimes it's pretty obvious, you know without a doubt which one to use. Okay, so we're looking at 2 and we're looking at 3. Okay, so there's also a base involved. You got to pay attention to bases because sometimes the bases do come in. And you'll see in this case the base will come in. So I see, I want to get a 60 and I need a 2 and a 3. So I know 2 times 3 is 6. So that's good. And I know 6 times 10 is 60. And those are all great numbers because 10 is that base 10, so really good. 3 is up there and the 2 is up there. So I got all the magic numbers. So now I just write it out in log form. Log 2 plus, remember we're doing product rule, plus log 3 plus log 10. Okay, now we're going to use the substitution, what we know. Well, we know that log 2 up here is m, so that just becomes an m. And we know log 3 is n, so it's m plus n. And we know that there's really a base 10 there. You can't see it's invisible. Base 10 to 10 is 1. Okay? And there's my answer. Okay. Well, this BU is a really obvious one. It's going to be the quotient one because it's already written in division. So all we're doing is going log 4 subtract log there we go, log 9. Well, I have a 4 and I need a 2. Well, I can do that. 2 squared. Okay, because 2 squared is 4. And I have a 9. I want to get a 3. 3 squared. Okay, so just manipulating numbers, I can get it to look what I want. So let's put the logs, and I got a minus sign, and log. Okay, so now, going back to what we learned earlier, powers come down in front, powers come down in front. So now we have 2, and we know what log 2 is. It's up here, it's m. So 2m, take away, and we know that 2 comes down in front, and we know this guy is log 3 is n. And there's our answer. Okay, the last thing we're going to do in this section is proving identities. What that means is I have an expression here and I want it to be identical to that, the same. Okay, when you're doing identities, when you're proving them, there's generally two rules with logarithms. There's the change the base rule, power rule, and there's the change the base rule, and there's the power rule. Okay. Now this one here, you can't see powers, but these guys will become powers when I just do some manipulating. Watch. So I have log. Remember, this becomes a to the negative 1. And I have x. Okay. Now say to yourself, well, I'm not going to use change of base. That's going to get me nowhere. But if I do the power rule, there's really a power here. You can't see it. There's a power 1 there. I'll just put it in. This comes as the numerator. This comes as the denominator. This is the Leslie-Whittaker rule. So this becomes 1 over negative 1, okay, of log a, base a, to x, which we can write as negative log a to x, okay? Now, I have to get this side into the same look as this side. So, well, I can write this as a power. Let's go right here. It's 1 over x, pretty easy. It'll become log base a to x to the negative 1, okay? Now we just do our old Leslie-Whittaker, come down and does the numerator, and there's really a 1 there. You can't see, I'll put a little 1 there because it helps us. That 1 in power in the base comes there. So it's negative 1 over 1 log a to the x, right? Which we know as negative is negative 1 divided by 1 is negative. And if you look at the left and right side, we have an identity. See, they equal each other. So that's one identity. Now the last one here is change of base. I don't see any powers going on. I can't change that b into a power. So it's change of base, which means log of the argument, which is x, over log of the base, b. Okay, so that's that. And this other bracket right here is change of base root. So log of the argument, which in this case is b, divides by log of x. Okay. Now let's use our crossing out skills or simplifying skills. Well, if I have a log x on the top and 1 on the bottom, they'll cancel each other out. Likewise, log b cancel. When everything cancels, you have a 1, and look at that. Over on this side, there's a 1. Check mark. And that's it.